The black mangrove is an invasive plant species. It's also a shallow marsh plant that can possibly overthrow the salt marsh ecosystem. They have long root bases that help support the plant while in the flooded conditions. One unique adaptation to the black mangrove is the seeds. The seeds have a thick leather casing that does not begin to sprout until it hits dry land. This allows them to survive while floating through the marsh system, and once they find a nice dry patch of dirt, they can actually plant themselves into the dirt.
Black mangrove was traditionally found in areas much further south than the Gulf Coast, like Central and South America. However, an uptick in the number of freeze-free winters, which leads to the plant not dying off annually, has caused the northern boundary of the black mangrove to expand even further north. This has led to the black mangrove expanding into salt marshes along the coast of the Gulf of Mexico in the southeastern United States. Many studies have sought out to better understand the effect that a salt marsh inhabited by both salt marsh grass and black mangrove will have on the rest of the ecosystem. In order to explore which conditions will be most favorable for the proliferation of black mangrove along the Gulf Coast, a group of scientists from the University of Houston studied black mangrove at 5 different points along the Texas coast, all with varying latitudes. These sites, Texas Point, Galveston Island, Port O'Connor, Port Aransas, and Port Isabel, can be seen on this figure. At these various field sites, the success of young black mangrove seedlings was analyzed. In order to analyze the differential success of black mangrove seedlings at these different locations, a series of transplants were performed. Young black mangrove seedlings were transplanted into the high, middle, and low part of the marsh in all of the locations. They were also transplanted in an area with and without neighboring plants in the area. As this figure shows, the black mangrove seedlings performed overwhelmingly better in the middle marsh. There is also a noticeable trend that the seedlings perform better when surrounded by neighboring plants. It is possible that the seedlings perform better when surrounded by neighbors because of the insulation from the cold that is provided by the neighboring plants.
A major concern is that mangroves are becoming so dominant that it will result in the salt marsh being taken over. This figure shows that as the mean annual minimum temperature increases, the percentage of salt marsh dominated wetlands dominated by mangrove forest increases. With just a 2 degrees Celsius temperature increase, you can really see how mangroves are taking over the salt marsh. Projective modeling in black mangrove intrusion has actually been really a key point in figuring out where black mangroves can expand to. Looking at this figure, you're looking at the presence and abundance of black mangroves projected at a low greenhouse gas emission. Low greenhouse gas is classified as any greenhouse gas emissions lower than the current average. So the presence, which is the top figure, is showing areas that are most probable to find black mangroves. So the black areas, or the gray areas, are more likely to have black mangroves in a low greenhouse gas emission. The abundance is the bottom figure. It is showing that these are the most heavily abundant areas, so therefore you'll have a higher density of mangroves in that area. This second figure is actually a figure that is projecting medium to high greenhouse gas emissions. And what that means is that it's current gas emissions and on the rise. If you look at the top figure, which is the presence figure, it shows the higher areas where you're more likely to see black mangroves. But if you look at the abundance picture, it shows where the highest density populations is of black mangroves. This is actually a lot different from the low greenhouse gas emissions, because you can actually see there's a lot more higher abundance areas. So that means that the black mangroves is practically taking over the salt marsh.
black mangroves are expanding into higher latitudes and often into areas that are dominated by salt marsh grass. We don't really know how this intrusion of black mangrove is going to continue to affect the salt marsh grass habitat, which is why it's very important that researchers continue to figure out how the habitat will be affected by the continued intrusion of black mangrove.